Looks like we're live. Hello everyone and welcome to yet another recreational programming session. Let's make a little bit of an announcement and officially start the stream as usual. So let's wait for Discord, right, for very fast application, live on Twitch. And what are we doing today on Twitch.television website? Today we're writing asset manager for Visualizer, right? So I'm going to give the link to where we're doing all of that, twitch.tv/tuning, and I'm going to ping everyone who's interested in being pinged. There we go. The stream has officially started. Today we continue working on Visualizer, which is music visualizer that we started to develop some time ago. So I'm going to copy paste the link in the chat for beautiful people on Twitch, and for beautiful people on YouTube, it's going to be in the description, right? In the description. So it's a very simple idea, right? So essentially you have an application which allows you to generate a pretty visualization of some music, right? So whatever music you want. So let's actually start it up. So this is how it looks like. It greets you with drag and drop music here, right? So this is how you're supposed to work with it. Let's grab some music, all right? So maybe this one, right? And as you can see, it starts visualizing, so it also has an interface, right? So you can actually jump to any point in the music. You can actually have several songs in here. You can switch between them, right, and stuff like that. And on the previous stream, we added an ability to actually go full screen, right? In case you just want visualization of particular music, or put it on the background or something like that, right? So, and at some point you can press, I think R, and it will start rendering the MP4 video of that visualization for that music, right? We're not going to do the full thing because it takes some time, because it's a high quality video, but you get the idea, right? You get the idea. That's basically a visualizer, right? It's a music visualizer. So on the previous stream, we worked with a little bit of assets, right? So we worked with a little bit of assets specifically to add icons, right? So essentially, you can see in here there is a button for full screen, and when you hover over it, it just like changes its icon, and when I press it, basically changes again, so it switches between the states and stuff like that. And developing this particular thing was it was okay, right? It was okay, but it was a little bit difficult to use hot reloading feature, right? So our application does in fact support hot reloading features. Yes, it is written in C, in a native programming language, but you still can hot reload things. And by hot reloading, I mean changing the behavior of the program without restarting the program. Yes, it is not intrinsic to web applications. You don't need a browser. You don't need a dynamic language to be able to hot reload programs, right? It's a basic feature of any modern operating system, right? I know it's kind of weird. It sounds kind of weird, but it's been common knowledge for decades. People just forgot about it. Isn't that contradicting to itself, right? So common knowledge and people forgot about it. I think these two statements are contradicting to each other. But anyway, right, so it's been a common thing for decades, right? People just forgot about it. So I can actually demonstrate you, right? So we can go to the source code in here. So we even have a table, right? So we even have a table for so-called accents. So color accent is basically this bluish color. Right, it's this bluish color. I can change this entire thing to, for example, red, right? So as far as I know, it's 0. And then I can go and simply rebuild this entire thing. And boom, I didn't restart the application. The application was not restarted, but the color accent has been changed. And the color was not saved in some sort of a text file. I literally modified the source code, C source code. I modified C source code. Without restarting the application, I reloaded the behavior. You can do that. So, but it's a little bit difficult with assets, right? So specifically, if I'm about to add a new button with a new icon, right, what I'll have to do? So I have a special structure, special God structure that stores the entire state of the application, right? So the way it works, in the memory, you have a chunk of memory that stores this state of the application, right? The whole state of the application. Then you have a chunk of memory that stores the code of the application that works on the data, on the state of the application. When you want to hot reload something, you unload the code, you retain the data, but you only unload the code and load a new version of the code that works with the previous data. If you change the schema of the data, you still have to reload the whole application. You still have to reload the whole application because the hot reloading feature does not work with the data. It only reloads the code. It doesn't reload the data. So because of that, right, so if I want to add a new image in here, I'll have to add a new field in here, right? Specifically, one of the buttons I would like to have in here, or one of the elements that I would like to have in here, is the control of the volume, right? And so what I'll have to do, I'll have to add a new field into the structure, volume, just a second, volume image, right? And also for the texture, of course, right? Because we have an image and the texture, so we can use that via the OpenGL. Right, and that will require the full reloading of the application, and that is not convenient. I want to be able to add new assets without having to reload everything, So, and the way we load, by the way, is so in the plugin init, so we just like call load that specific file by that specific path, right? So load that specific file by that specific path. And so what, I was thinking how we can solve all of that. And I suppose the most logical solution would be to have some sort of a cache, like a cache asset manager. I don't even know how to call that. I suppose different people call that slightly differently, right? But essentially we can have some sort of a asset structure, right? It doesn't really matter what exactly it is, right? We can define it right before the plugin, right? So somewhere here, and within the plugin system, we're going to have not assert assets, right? It's just reflexes. So maybe even assets, because there are several of them. So this is assets. And essentially, we can have different methods for that specific class, for that specific structure. For example, we can say asset image load, and here we'll accept file path to the image that you want to load, and this entire thing is going to return an image. So how is that different from just loading the image? Well, it's going to cache that specific path. Right, so basically, when you try to do asset load somewhere for the first time, it will call the image load. And then when you do that for the second time with the same path that was already loaded, it is not going to load anything. It will return you already cached thing. So, and the way you are supposed to use that, right, as the way I envision you're supposed to use that. So let's actually find something like screen, maybe texture. I think texture is going to be better. So in that case, maybe we want to have something like texture 2D, texture load, right? So full screen texture. And let me see. So as you can see, I want to try to draw a texture. Instead of using that field of the plugin, I would do something like asset texture load, right? Asset texture load, and I would provide resources, icons, full screen PNG, like literally like that. When this thing is called for the first time, of course, it's going to be a little bit slower. It's going to load the file, but then on the next frame, right? So it's going to be called on each frame. On the next frame is going to return that texture from a cache, So, and here is an interesting trick. So every time we want to refer to an asset, we're going to be doing that through these kind of methods that cache everything, right? So, and when you are about to reload the plugin, so we have a pre-reload, we're going to have something like asset unload everything, right? Before reloading the plugin, we tell the asset manager, unload everything you have in the cache. Right, then the code reloads itself and it starts to call into all of these, asset things again, and it loads new versions of everything. And if it starts to call to a new asset that was not loaded before, it's going to be loaded as well. Right, so it sort of like refreshes the whole asset catalog. right? So this is basically how I see that. And that way I will be able to add new icons and new buttons and stuff like that using hot reloading without reloading, without restarting the whole application over and over again. So I think that's actually kind of an interesting idea. I think this is how it's done in game development. At least this is what I heard game developers do. Right, I'm not a game developer myself. I know nothing about like game development. I only heard some rumors and stuff like that. So, but I think this is how you do that. And since we sort of have this our own abstraction layer over the assets, it doesn't really matter where the assets are coming from. Right, so load texture, right, so where's the load texture? Let's find it. Load texture load. I called it texture load for some reason. Okay, so it doesn't really matter where they're coming from, right? So we here assume that it's coming from the file system, but nothing stops us then later pack the entire resource folder into like a single bundle, like a webpack bundle, right? If I'm gonna switch to your Zoomer terminology, right? Zoomer web terminology, we're gonna have like a sort of a bundle, webpack bundle of all of the resources, and then within that bundle we're gonna have a map from this path ID to a sequence of bytes, which is the content of the file, and that way we have everything compressed and packed into a single thing, which makes it easier to ship to the end user. Or maybe we can bake the entire bundle into the executable, so everything is within the executable, so it's like easier to maintain, so we don't have to deal with current working directory or anything like that. Right, when we are in a development mode, all of that is of course in the file system, right, because you want to be able to modify the file system and see the changes right away. But when you're shipping that, right, in a release mode, you can actually pack everything together, right? So similar to Webpack, right? It's almost like a Webpack for you Zoomers out there, right? So sounds good, sounds Gucci, sounds Atamaguchi. This is exactly what I want to implement today, right? So that's basically the topic for today's stream. All right, let's go ahead and do that. So I think I'm going to just discard all of the changes that I've done so far. I can even try to rebuild the entire thing, and boom, so it is back, right? It is back. So let's go ahead and maybe introduce that magical asset manager. Right, so plug. Where is the plug? Excuse me. Type def struct, and this is going to be assets. So how are we going to go about that? So obviously it's going to be some sort of associative array or something, right? I don't know how it's called. Yeah, associative array. So it would be nice to just have hash tables like you do in any modern programming language, right? But we are programming in C, right? So programming in C, and because of that we can't just have this kind of stuff, right? So we obviously need to have things for images, right? So something like images, right? Then we need to have things for textures, right? For textures. Do we need anything for sounds? We managing sounds slightly differently, so it doesn't really matter. I also want to actually store in assets things like fonts, right? So I definitely want to store things like fonts, right? So then textures, fonts. And then we probably need shaders. Actually, storing shaders in assets, a good idea. I think it is a good idea. It will make it easier to just like work with them in the future. Right, but the problem with shaders is that we may have several of them, right? So we may have like vertex shader and fragment shader, right? So how we're gonna store them? And so to be fair, like when you do load shader, right? When you do load shader, okay, so you provide like two of these things. So the shader actually has two IDs, right? So it has two IDs for the fragment and for the vertex. It can be missing and stuff like that. So maybe I'm not gonna go into the shaders right away, right? So I'm not gonna go into the shaders right away. I'm gonna stop at images, textures, and fonts, right, at images, textures, and fonts. So let's go ahead and maybe create a structure for images, right? So this is going to be images, and we're probably going to have like items, right? So these are the items. So I'm thinking about, I want to have images as dynamic array, but at the same time, I want it to be like a hash table, so to speak, if that makes any sense, right? So it would be kind of nice for that thing to be a hash table. But that means that this has to be something more than images, right? Because we need to store the key somewhere, right? We need to store the key somewhere. So maybe we need to have image key value, or maybe image item, but something, right? So maybe we need to have some sort of an additional structure that stores the key, right? So there's going to be the key and the value itself, which is the image, right? So, and essentially, yeah, there we go. So, and in here you would have something like size t, count, and capacity, right? So something like this, right? So you have a key, you have a value, and so on and so forth, right? So that way we can probably use di append, the usual di append from knob that I like to use all the time. So it's a very simple macro. So let me find where knob is located. So knob di append. So yeah, there we go. So it's a very simple macro that just implements dynamic arrays, right? That implements dynamic arrays. So it would be also nice to quickly find a thing within the images, right? So quickly find a thing within the images. But can I make it a more generic thing? Can I make it a more generic thing? So probably not, because one of the reasons why di append is generic is because it's a statement. It doesn't return anything. When you need to return something, it's kind of difficult to make such macro, right? It's kind of difficult to make such macro. So, but we can create something like images get by key, right? So maybe find, right? Let's just call it find. So, and in here we accept the images and the key. And what we can do in here, we can just go ahead and find this entire thing linearly. I know that all of the CS students are literally shaking and crying right now because their professor told them that you're not supposed to use linear arrays because they're slow, right? You're supposed to use hash tables, you're supposed to use trees because that's what their professor told them to use in these particular situations. And the reason why these CS students trust their professors is because they paid huge amount of money to get this piece of paper so they can have a job in some mediocre company, right, and paid average salary, right? So they spend a lot of money so they can go into this elite club, and that's why they're literally believing everything their professor telling them, and their professor told them that you're not supposed to do things like that. And partially I do agree with that statement that it is slow, right, because it's linear, right? But we are not going for the speed right now. We're not going for the speed right now. We're just trying to implement something that will work, right? We are trying to implement something that will work. And essentially, if we write a code that uses that specific interface, and then at some point that code becomes slow, we can just take whatever we have inside of this function and re-implement it using hash tables, and the code that uses this interface doesn't have to be changed at all. It doesn't have to be changed at all. So we are consolidating the place where we have to make the changes to speed up this code. It is fine. That's what I'm saying. It is fine. I know that your professor told you that you're not supposed to do it like that, right? But we're making it so in the future it is super easy to speed it up when it's actually needed. When it's actually needed. Calm down. Everything's gonna be fine. Just breathe. I know that you spend a lot of money to get into university and your professor told you that you're not supposed to do it like that, but calm down. This is just a random stream on the internet. Okay, everything's gonna be fine. This code is not gonna hurt you. You're not gonna support this code. You don't even have to submit any pull requests. Just breathe. Everything's gonna be fine. Yes, we're gonna be using linear algorithm. Right. Because it's kind of weird how much CS education radicalizes people, right? To the point that when they see a linear search, they literally start shaking and crying and screaming, right? I do agree, it is slow, but right now it is fine. And when it's not fine, it's easy to fix it. Again, right now it is fine, but when it becomes not fine, it is easy to fix it. You get it. You get the idea. I passed 3 years of uni doing linear searches. Yeah, what's funny is that the majority of situations you're going to be doing that anyway. So, but at the same time, you need to know how, in case of an emergency, how to speed that thing up, right? So, how to speed that thing up. And we're definitely going to be using hash tables in here, like 100%, like I guarantee you, because as we add more and more different assets and stuff like that, it's probably going to be slow, especially considering that we're going to be calling this function on each frame, right? We're going to be calling this function on each frame. Furthermore, we're probably going to pre-compute the hashes for the keys. Right, we're probably going to pre-compute the hashes for the keys, so you don't have to compute the hash of the string on each individual frame. So essentially, on each individual frame, you kind of know what kind of asset you want to query from the asset manager. Why not pre-compute the hash of that asset, and instead of using the string as the key, use the hash as the key? Right, and to make it work, we'll probably have to use a perfect hash table, right? So, and since we know upfront how many resources we have, we can quite easily build a perfect hash. You see what I'm talking about? Right, so essentially, once we get this thing to optimize as much as possible, getting an asset on each individual frame is going to be as fast as looking up an element of an array by an index, right? If you have a perfect hash table. And it's easy to build a perfect hash table in here because we know all of the keys up front. We know all of the keys up front. We can pre-compute their caches and stuff like that. We can even automate the entire process. All right, so we're gonna do in here. So we're gonna just iterate this entire scheiße images count plus I. And so what we're gonna do in here, if strcmp, so images items, so this is gonna be I, we take key, so this is the first thing, and the key in here, and if this thing is equal to 0, we can right away just return the pointer to this entire thing. Right, but we are returning like an image, right? So returning like an image. So maybe we just have to do the value in here. So we are returning the value, and if we couldn't find anything, we just return null, right? So we just return null, just return null. So yes. Similar thing with textures, right? So, and I wonder how can I basically generalize this entire interface. I'm not sure if I can easily generalize it, right? Because I want to have a similar thing for the textures, right? So I want to have a similar thing for the textures. Right, so in here we're going to have a texture 2D. So this is a texture item. This is the texture item, and this is the textures, right? So this is the textures, and you basically repeat this entire stuff, but for the textures. It would be kind of cool if I could just use a macro, right? In here, just turn this entire thing into a macro. But then the macro is supposed to return something, right? It's supposed to return something, and you can't return things from macro. You can't return things from macro. And on top of that, so you can only use string as the key. You can only use a string as a key. Excuse me. So if you want to use something else, it's going to be a problem. But let's actually not try to maybe generalize it too much. Let's not try to generalize it too much. We can come up with a very interesting sort of function. We can come up with a very interesting function. So let's actually go back. Right, so let's go back. And we can accept maybe pointer to the beginning of the items. Right, so we accept the pointer to the beginning of the items, like to here. Right, we're starting to think in terms of like assembly. We're going down to assembly. So here we're going to just have that. So let's actually think it like that. So essentially you have items in here, right? And you have a pointer to that. So this is the items, and we're passing this entire thing in here. So what we need to be able to do, we need to be able to actually get to the next item somehow. To get to the next item, we need to know the size of that item. So we can pass that as a parameter as well, item size. You see, we're actually stripping off the types. We're stripping off the types, and we're talking about like actual sizes in bytes of the elements in memory, right? So because that's the easiest way to write generic code in C. Right, so once we know how to get to the next item, we need to know how many items we have. So let's actually pass items count, right? So it's a lot of different parameters, but we're gonna hide all of that behind other macros, right? So you will see, this is an interesting trick. This is actually a very interesting trick. Okay, so we know the size of the item, we know some other things, and interestingly, we can essentially assume that the key is always going to be a string. The key is always going to be the string, so we know, right, we know how much space does the key take within the item. We know how much space does the key take within the item. It's 8 bytes. So we know that. And because of that, we know where to search for the value, right? Where to search for the value. And we know the size of the value because we know the size of the whole element and the size of the key. So we can take the size of the whole element, subtract the size of the whole key, and we know the size of the value. We know the size of the value. So essentially, this is enough information to actually find all of the necessary elements in here. It's enough to find a specific image item, it's enough to find the key, it's enough to find the value, regardless of the type of the value. Regardless of the type of the value. Oh yeah, there's also padding, get them. Okay. But I mean, here's an interesting thing. Key is 8 bytes. So I'm pretty sure like whatever we have in there, like you can just add 8 bytes to the beginning of the item and you will get to the value, maybe? I mean, we can pass an additional information for the value, but I mean, is that... Yeah, we'll need to think how bad the entire thing is. We can always pass the item value offset, if that's, you know, if that tickles your fancy, right? So something like item value offset, and then when we call to this function, we can always use offset of, right, of certain thing. So to take into account the padding and stuff like that. Is that something better? The padding people in the chat? Like, can you see, by the way, what I'm doing in here? So So the padding people in the chat, what do you guys think? Is that a better solution? So essentially we have the pointer to the beginning of the items, the item size, the item count, right? We know that key starts at the beginning, and then just to take into account the padding, we're going to have item value offset just in case. Desu used says padding is cringe. I agree with that, I guess, but it's needed on some platforms, I suppose, right? It's kind of required. I heard there is this very scary platforms where if you do unaligned reads and writes, you're going to be slapped in the face really, really hard to the point that you're going to be stripped of your CS degree and you will never be allowed to work in programming ever again. These kind of platforms, you know. So anyway, yeah. It is cringe, but it is what it is. So on top of that, we need to accept the key, right? So we also have to accept the key, and that's basically it. That is essentially it. And we can say, maybe we can call this entire thing not even images find, but assoc find. So associative array find, right? Assoc find. Okay, cool. Now, so we can start basically copying this algorithm, but accessing the arrays using this information that we passed in here, right? Using this information. So let's see how we can do that. So we know how many items we have in here, so it's pretty easy to organize the loop. So this is going to be items count, right? So this is the items count. There we go. We organized the loop, and at the end of the loop, of course, if we didn't find anything, we have to put null in here. There you go. So then we need to access the ith element. We need to access the ith element. So we need to take the pointer to the beginning of the items, right? So where is my thingy in here? So we take the pointer to the beginning of the items, and we have to add items to that specific thing. But here is the interesting thing. So we have to be very careful. Items is a void. And it is usually not allowed in C to do arithmetic, like pointer arithmetic on voids, because void doesn't store information about the elements, right? So it doesn't know how to properly offset. Usually it basically defaults to size of the element 1, but it's not recommended to do it like that. So one of the things we want to do, we want to cast this entire thing to a pointer to the element with size of 1 byte, and those we're doing 1 byte pointer arithmetics, right? So by doing things like that, we essentially, located some sort of item in here, right? So now we know this is the pointer to the item, right? So we can even do something like pointer item. Right. So, and what's interesting is that we know that the key is located at the very edge of the item, right? So the key is literally located somewhere here. So let me actually replace this item to something like this, right? So here's the key. 1, 2. God damn it, it's actually 2. But yeah, you get the idea. So this is the key. What we can do now. Where am I? We can cast this entire thing to const char ** and simply dereference this entire thing, and we got the key which we can compare things with. Look at that. Look at that. Look at this expression. This is how you write generic code in C. Templates? Who fucking need templates? Just use pointer arithmetics. Now that's the peak of software development. You may not fucking like that. You may not like that, but that's the peak software development. Anyway, so item key. Let's actually call it item key. So we can even probably just split this into like separate things. Like for instance here, I can do something like void star item. There you go. We located an item. Then we take this thing, we cast it to this specific pointer, and we dereference, right? So this is the item key. And then we can have another thing, which is item value, right? So this is going to be item value. And item value is essentially, we might as well maybe keep it as char, so it's easier to do arithmetics with this kind of stuff. Item value offset, right? So item value offset. And then since it's sort of like a, yeah, it's sort of like a pointer, right? And we store the value by value, we can actually keep it like that, right? So we don't really have to, do anything in here. And that's basically it. That is basically it. If, so strcmp key and item key are equal to 0, we found an item and we can just return the item value. There we go. So we can just return the item value. Yeah. We don't even have to wrap this in parentheses. I suppose maybe this wrapping in parentheses also is not particularly needed, but it's not that much complicated than this thing, right? It's just like we're working with the sizes of the elements ourselves. We stripped off the type information and we're working with this stuff like this, which, by the way, quite often people make an argument that because of that C is slower than languages like C++ and Rust, because in C++ and Rust you have generics and templates and stuff like that, and so the compiler knows more information about the types than, for example, in this specific case, right? So, for example, the size of the type here became a runtime value rather than a compile time value, right? So you see the point. Right, so in languages like Rust and C++, this is the value that the compiler knows. But in C, it's a runtime, so it doesn't know, and because of that, Rust and C++ are, faster than C on average or something like that. But I wonder if you have a very aggressive C compiler. Can that aggressive C compiler inline so much stuff that it basically knows the size of this thing? Because the way you're supposed to use this thing, by the way, you're supposed to create some sort of a macro, right? So you're supposed to create some sort of a macro, something like, let's call it find, right? And in here, you're supposed to pass this images thing in, right? So it's going to be, well, let's call it table and the key. And you do assoc find, you take table items, right? So you basically give it the pointer. Then you can take the size of the item, right? Size of items 0. And then what you're supposed to do, items count is going to be, so table count. So this is how many items you have. And then value offset, you probably need to something like offset of. And this is where it becomes kind of painful, right? So, but essentially you can probably do something like, I forgot how to do offset of. The problem with offset of is that you need to have a type, right? You need to have a type, but there was a way to do that without a type. But I forgot how to do that. So I think I'm going to accept the type like this right now, and I'm going to fix that a little bit later. So here you have to do the value, so this is that, and then you pass the key. Okay, so that's besides the point. That's besides the point how exactly you take the offset, right? So then you do find, and then images, and some sort of like a resources, icons, full screen, PNG. Right, so that will get expanded into this thing. Size of is known at compile time, and since we have this hypothetical aggressive C compiler, since it's known at compile time, it will inline it and maybe evaluate something inside of this thing and still kind of know the size of the of the items and still apply some sort of a optimizations. So this is what I was trying to say, right? So even though C++ and Rust compilers, they do in fact know more about types at compile time, if you have this hypothetical aggressive C compiler, maybe it also knows enough at compile time and can achieve the same thing. But I know personally, it would be better if C just had some sort of a mechanism for generic functions, right? So the same way, for example, Jai implements them, right? It's just, it's not even about performance. It's about like ergonomics and convenience to use, because this shit is not fucking convenient to use. Like, I don't care if there is a C compiler that makes this fast. I literally don't give a shit if it could be as fast as in Rust. I couldn't give a shit. Just make it less painful. You know what I'm talking about, right? You know what I'm talking about? It's not about performance at this point anymore. It's just like about ergonomics. Just check with Godbolt. Well, I mean, to check it with Godbolt, I need to make it compilable. This shit is not compilable yet. So, you know what I'm talking about? Right. So let me see. So maybe one of the things we want to do, I want to have some sort of a playground where I could play with this entire thing, but I'm not quite sure. So, so let me copy paste this entire stuff to maybe assoc.c, and this is what we're gonna have in here. So maybe here we're gonna have an integer, right? So this is gonna be int item. This is the int items, and this is ints. Right, so this is ints. So we have a assoc value, and here we can have int find, ints find. Right, so and in here, oh, by the way, since we kind of know the type, we can have table items, items, table count. Here it's ints value and a key, right? Ints value and a key. So what we want to do in here, I would like to maybe create ints and just populate it with something. Right, so let's call it access, something like this. Now we probably want to include knob. I think knob is located in assoc knob.h, and I'm going to define knob implementation, right? So this is the knob implementation, which allow me to append thing into that stuff, right? It would allow me to append things, right? So let's start iterating from 0 to 10, right? So we're going to have something like this, and I should be able to int item ii. So we already made the key a string. God fucking damn it. All right, so that means we need to have some sort of keys in here. Const char keys. What kind of keys we can have in here? So let's say hello world foo bar buzz your mom, right? Okay, so and that means that what we're going to be iterating in here, we're going to be iterating from knob array len, right? Knob array len keys, right? So let me actually try to print this entire thing. Keys I, right? So let's do clang o assoc.c. Let's just run it. Let's just run it. So we forgot the semicolon in here. There we go. So hello world foo bar buzz your mom. Cool. So now int item ii. So the key in here is going to be let's keep it as integer. The fuck is going on Emacs? Keys I, and the value is going to be I. Right. So after that, knob di append, no di access ii. So we're just copying this entire stuff in here. Just copying this entire stuff in here. So maybe I'm gonna build this entire thing with GDB, right? And then look at this thing from the debugger, right? Just to see, because I don't want to print anything in here. So it's gonna be assoc, and let me see. So let's break at main and let's run it right away. And maybe run until here, and we are ready to take a look at access. What do we have in access? So we have 6 of these things. Here are the items. We can't really see all of them, so maybe I want to do something like items, dereference this entire thing, but take exactly count of them. And there we go. Here are all of the items that we can have in here. You can just see them. So there you go. So hello world foobar buzz your mom 0 1 2 3 4 5. So here are all of the items in here. So that's pretty cool, isn't it? I think that's pretty cool. So the next thing we want to do, we want to maybe take you know, think by a value, right? So let's do ints find. We provide access. Do we provide access as by value? Yeah, we do provide it by value. Okay, so we provide it by value, and what we're trying to find, maybe foo. So this is going to be 0 1 2. Foo is going to be 2. Right. And we can even say the type. We can even cast this entire thing to the type, right? So because we know the type in here, so we can make it a little bit more type safe. Isn't it cool? I think it's pretty cool actually. Right. So we can have a value in here, and we can then have stuff like if value is equal to null, right, we can say printf could error could not find key s, and this is going to be key, and we can move this key to a separate variable. So this is going to be key, like so. There we go, and we can exit with non-zero exit code, right. And then if everything is fine, we can say something like this, right? So this is going to be key, and this is going to be value that we managed to dereference. And this entire thing is still type safe. And this entire thing is still type safe, right? So because we cast the corresponding types and stuff like that, but we still have a generic algorithm that searches through all of that stuff. Okay, guys, so let's try to compile this entire thing. We're not going to run it, right? So it does not compile. So implicit declaration of offsetof. Okay, so offsetof, where it is located. I think I have to include something to just have an access to, or maybe I did a fucky wacky. It's actually single F. Okay, so dyslexia, freaking dyslexia. Okay, it didn't really help. All right, this is because I have to provide the type of int item. All right, so int item. So that's what I have to do. I have to provide the type of int item. It's still implicit declaration. Okay, so I have to probably do std_def then, right? So std_def, or maybe std_lib. Std_lib usually includes std_def. No, it's not enough. So what about def then? Okay, so def is like, I thought. For some reason, for the longest time, I thought that if you included std_lib, it also kind of implies std_def. Was it not implying that? Like, okay, sure. I mean, I'm not a C specialist, right? I don't really know much about C. I'm sorry. And let's actually try to run. So everything seems to be compiling. So can I just run this entire? And it's 2. Look at that. So yeah, it's 2. So it's kind of cool actually, right? Because now it doesn't really matter what kind of value, what kind of type of value I have in here, right? So this code works with any of them because it doesn't work on the level of types, right? It doesn't work on the level of types. It works on the level of offsets and stuff like that. So speaking of aggressive optimizing C compiler, right? Aggressive optimizing C compiler. Well, I won't be able to just copy paste it to Godbolt because I need something from knob. Let's actually try to comment out this entire thing. Let's try to comment out this entire thing. So strcmp, so we need string. I'm gonna copy paste stuff from knob, so I can copy paste all of that into Godbolt. Not Godbolt, Godbolt. Freaking Godbolt, and it's just like. Naming. Same shit. Okay. Nope. Alright, so it's gonna compile, we'll see. Oh yeah, so you need to have the init cap. Init the cap. Alright, so implicit declaration of nob_realloc. Okay, so let's bring it there, nob_realloc. Sure. Maybe it needs also assert, just in case I'm gonna put assert there as well, just for you. So, assert, it needs assert here as well. Go, you're happy, you're happy, okay. Godbolt. Made by Matt Godot. My favorite C++ developer, Matt Godot. I'm so sorry. I'm so sorry. So, let's go. Okay, close. Close the Scheiße, meine Freunde. Compilation. This shit failed to compile. Okay, so what's wrong with that? Assert? Really? So, what are you saying, bruv? Assert.h file not found. Am I? WebAssembly clang. Who uses WebAssembly in 2023, bruh? Clang. Okay. So let's use this one. Okay. Assoc find. How can I know if this thing is aggressive enough or not? How can I know that? So okay, I'm looking at the assembly, but that doesn't really tell me that much. Add 8. Right, add 8. So it adds 8, but it's the size of the pointer. Doing some stuff. Okay. Anyway, so I'm kind of not in the mood of reading all of that and trying to comprehend it, so I'm really sorry. I could have actually, why did I have to use Godot by Matt Godot if I could use the debugger, right? So because I can do all of that in debugger. And it could be actually more readable if you think about it, right? So it could be more readable. Right, so let's give it a try. So I'm going to break at this, and there you go. I can do Control D. Can your Godot do that? Can your Godot do that? I don't fucking think so. Anyway, so but we don't. Yeah, so for instance, item size, it uses a runtime value of item size. This was a good idea, by the way. This was a good idea. I really like that. Because here, this is straight up like a runtime value, right? So it didn't, yeah. And it also, I didn't compile with any optimizations. It does imul and stuff, right? So I'm pretty sure we need to compile with all of the optimizations. Right, so won't compile, disable optimizations. Optimizations are already baked into the executable. Right. So optimizations is how the compiler arranged final instructions that are going to be executed at CPU. Debugger does not reverse optimization by modifying the instructions that are already generated by the compiler. It's not how it works, right? This is not. Imagine debugger, when you run it, analyzes your executable, spots the patterns of the compiler, and physically reverses them by undoing them in a sequence of instructions. That would be actually hardcore, right? So this is not how it works. Right, this is not how it works for sure. Anyway, so let's actually try to enable a lot of optimizations. So, and let's break assoc find, and let's run this into Scheiße. And what? Okay, so, oof, 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 oof. All right. So yeah, we lost any resemblance of the original code. Wait a second. I think it literally like inlined. Holy shit. It's entirely inlined. Yeah. Yeah. God damn. That's hardcore. Bruh. That's literally hardcore. Holy shit. Yeah. Pretty cool. Anyway. So we have this thing. So, and my point is that, right, so this thing is generic, but then with the right macro wrapper, it still can stay type safe, right? It still can stay type safe, right? So it just automatically detects the size of the items, it automatically detects the size of the value and everything. So it's kind of close to how I do dynamic arrays. And maybe eventually I can turn this into like a hash table, right? So, and if you want to define your own hash table, you probably need to do something like this. Right, you need to do something like this. So you can do assoc find, and if you want to add a new thing in here, you just add it like that. But we need a more convenient way to add an element to this assoc array, right? So we definitely need a more convenient way of adding things, because right now to add a new element, you need to allocate this kind of thing on a stack, right? So this kind of thing on a stack, and then do da append, which is not particularly convenient. So if we're going to have a macro that does that for us automatically, so I want to be able to do something like assoc append, where I can just do access keys I. That's what I want to be able to do. Right. And how can I even construct such macro? How can I even construct such macro? Oh, by the way, if I manage to somehow get rid of this thing, I can make it more generic even, but I'll have to think about that. Okay, I've been doing all of that for almost an hour, so I would like to maybe make a small break and refill my cup of tea. And after a small break, we're going to continue experimenting with this thing. I know, okay, so I'm going to say it up front. I could have just taken implementation of hash table from STB. I could have just done that. But I kind of want you to experiment with this kind of thing, right? So if anyone just wants a hash table in C, you can just grab this thing, right? It's like a ready-to-use implementation of hash table in C. It's stbds, and it also has dynamic array implementation and stuff like that. So I'm going to copy-paste it in the chat, and for people on YouTube, it's going to be here as well, right? So you can just use that. And what's funny is that that library does that like roughly under the hood. It makes a couple of different technical decisions, but roughly it does that. So specifically what it does differently, it stores its meta information about like item size, item offset and stuff like that in a hidden header right before the beginning of the array. So it kind of abstracts that away from you. I don't like that for a number of reasons, primarily because it's hides a lot of technical details from the user of the API, right? So it's just like tries to hide this header, and it's just like I don't particularly like it. I like when everything is exposed and it's clear how this entire thing works, even though it might be not particularly convenient all the time. Right, and on top of that, I would like to just explore this thing myself. Because it's kind of fun, right? So I'm into these computer science and low-level things. And so you are, because you're watching the stream. So yeah, why not explore? Because it's kind of fun, like, you know, manipulating bits and then watching how that works in a debugger. It's kind of interesting, right? So I think it's kind of interesting. So anyway, let's make a small break. I'm gonna refill my cup of tea and we're gonna get back to this entire thing and see what we can do. All right, so one of the things I wanna do, I wanna find a way to supply just the value in offset of except of the except the type instead of type. Jesus Christ. So in here, the documentation says that you have to supply the type, right? So it has to be some sort of a pod type and everything. And what I want to be able to do, I want to be able to say, bruh, accept the this thing, right? Accept this thing. So maybe it would be better to maybe do something like this. Right, so we can see each individual thing in here. My neighbors are fucking screaming like crazy motherfuckers right now. Probably because I live in Russia, so that's why. Fucking animals, I swear to God. Anyway, so I want to be able to do this kind of stuff, right? So I want to be able to do this kind of stuff. So here I probably want to also you know, wrap it around, because you never know how many tokens are going to be supplied in here, right? So here's an interesting sort of like a rule of thumb. When you write in a macro, don't think about arguments as values. Think about them as an array of tokens that are going to be expanded in here, right? You don't know how many tokens key is going to become, right? And one of the tokens in the key could be comma, maybe. Well, I mean, you can't really pass a comma in here without like making a syntactical error of expanding a macro. But I mean, you never know what kind of shit you're gonna have in here. But I mean, maybe that's fine. So this is one of the reasons why I put this thing in parentheses as well, because you never know how many tokens this thing is gonna be, right? Yeah, you can pass it if you put parentheses in here, yeah, so you can do something like that, right? And it can screw up things, I suppose. But can it? I don't freaking know. But it's just like a, you know, precaution. Yeah, I basically do that as a habit, just in case. Percussion, right? Okay, so you can't really do that, right? So you can't put a value in here. This is not a thing that you can actually do, right? So if I try to compile this entire thing, it's going to complain, right? So implicit declaration of assoc append, well, this does not exist, that's fine. So int find, and within this thing, it complains about this thing being a value. So one of the way we can solve that, right? So I want to find the offset of value. So you can always take the pointer to the value, right? So essentially, you have an element. You have a key, you have a value, and here is the element. If you take a pointer to a value, you get a pointer to here. If you take a pointer to the element itself, to just the element itself, you get the pointer to here. Well, technically, if both of them were pointers to character, you could have just like subtract one from another, and that would have been your offset. Know what I'm talking about? Right? So so people suggesting to use things like typeof, but the question is typeof a standard thing? Offsetof is a standard thing, typeof, right? So as far as I know, in majority of the situation, it is extension. C23. Are you a Rust developer? You sound like a Rust developer. You know why? Because it's fixed nightly. Oh! I swear to God, every time I use Rust, I quite often encounter some sort of like mild inconvenience. And you guess what? It's already fixed nightly, and it's been like that for like 5 years. For 5 years, I occasionally try to use Rust. I encounter some mild inconvenience, and you guess what was the response of the Rust developers? That's fixed nightly. And it never fucking changes. It's like 5 years, same shit. It's insane how consistent it is. Would you like it not to be fixed at all? Yeah, that's kind of interesting. Just like C, right? In C, it's always inconvenient and it's never fixed. I can't use that shit. So let's continue. Can we do it like that? Well, I mean, we can probably just like put this shit in here, and we never have to know the type of this entire stuff, right? So we never have to know it. Boom. So this, we can even say this is a assoc find, and this is sort of like an internal implementation. Right, some sort of an internal implementation that you know, has underscore in its name. Right. So yeah, so, and this is a macro that sort of like extracts all of this necessary information, right? Extracts all this necessary information. Basically, this macro does the job of the compiler. This is what the compiler is supposed to do for me, but for some freaking reason, I have to do that myself. Anyways, so that's pretty cool. So we can do assoc find, and maybe, yeah, let's actually try to recompile this entire thing and try to run it. And it seems to be working. So I think that's a reasonable way to compute offset, right? Since it's behind the macro anyway, it doesn't really matter that it's so weird and so big and stuff like that, because it's behind the macro anyway, right? So nobody's gonna see that, right? So we just tucked it away, so don't think about it too much, right? So, and yeah, so now this entire thing works, and I can now even have a thing that replaces ints with floats, right? So now I can use floats in here if I want to. Right, so it can be replaced like so. So this is float. I don't really have to do it like that, so I want to make it int, and here we're gonna just cast it to float, and this is gonna be float. And when I'm printing this entire thing, I'm gonna be printing float. So yeah, it doesn't really matter. So it really doesn't care about the type. It only cares about this specific definition. Right, people quite often ask me, right, why I like to define this kind of structures manually. Why do I like to define this kind of structure manually, and why didn't I create some sort of a template instantiator, right? So where I would say, okay, define, you know, assoc, where I would have a type, and here I would have like the type, then the type something something and stuff like that. And this is because I want this thing to be Typey. Right, for instance, I want to be able to say, okay, this is not ints anymore, this is samples, and this thing now also contains some additional things, like for example, file path where I save all of that, right? But since this thing still contains all of the fields those macros expect, it still acts like associative array. You know what I'm talking about? Right, so the thing about this macro is that they expect a very specific set of fields, and they don't care if you have more fields. So it's sort of like a duck typing. And that's why I define them manually, because maybe I will want to add more fields in there for some other things. Right, so one thing could be several things simultaneously. This thing is simultaneously associative array and dynamic array. Right, you see? So essentially, I use a macro for dynamic arrays, and then I use macro for associative arrays. So this thing is sort of like, it just like adapts depending on where you put it, right? It's duck typing. You see what I mean? This makes sense, right? That's why I just like explicitly like to define it, because I can explicitly control what kind of interfaces it conforms to, if that makes any sense. So I know it's a little bit more additional work, but I kind of do that so just like a as a mental checklist or something. I don't know, it's kind of difficult to explain. It's just like some sort of a preference that I have. So that's pretty cool. So we have assoc, and it's more or less generic, but again, I would like to have assoc append that doesn't require this kind of stuff, but maybe that's fine. Maybe that's fine for this specific thing. And yeah, I suppose that is basically it. I can now copy paste this stuff to the plugin, right? So this is where we were doing all of these experimentations. I can remove all of that. So now we have this assoc find. We have images item, and we can quite easily work with all of that. And also we may have textures. Right, we may have textures. So this is probably going to be like an image texture 2D, boom, and fonts, right. I can replace texture 2D, maybe I'll do it like that, font. It's kind of an interesting interesting type. So maybe I should get rid of the 2D, because if I remember correctly, just texture is enough in the terminology of Raylib, right? I think it is enough in the terminology of Raylib. So we have that. So now we should be able to just work with all of that. So do I have assets? Assets, there we go. And if I try to rebuild this entire thing, what is going to happen? Okay, so that built first try. That built first try. So we want to have these sort of functions that allows to, you know, track like query specific things, right? So as asset, assets, image, assets image. Let's just call it assets image. So we're gonna accept assets by a pointer. We could actually, but it kind of makes it difficult to query, right? So if we're gonna accept assets like that, right? So we always will have to call assets image with p assets and stuff like this. And p is a global thing anyway. So maybe we could make assets image to automatically extract the assets itself. So this is something that probably makes sense, I think. I think it probably makes sense. Right, so here we have something like const char file path. So that's fine. So, and essentially we can do assets, assets, images. Assoc find, we're trying to find the file path. Right, and that should give us the image. So this is the image. And what the fuck is this? If image is available, we just return that image. So we always return it, right? So we always return it. If it's not available, right? So if it is equal to null, what we have to do, we have to load it somehow, right? But the word image is already taken, right? The word image is already taken. Maybe we have to do something else, or maybe we can actually put that inside of the scope, so we can reuse the name image, right? So and just load image. Just load image file path. It can fail, but it's fine in the context of a Raylib. So it kind of allows you to load, to actually, for this kind of operations to fail, right? So it's still kind of valid image. It's just like not going to be displayed properly anyway, right? So it's kind of fine. So we load the image, and the next thing we need to do, we need to have image item. All right, so this is going to be the item. And interestingly, maybe it would make sense to actually do it like that. Right, so item image, and that frees up the name image, so we can get rid of the scope. It's kind of funny, right? So this is because I cannot plan things ahead, right? So I cannot simulate the code in my head. I have to write it first, and only then see that you can do it like that. Right. For example, when I was writing this code, like I didn't think that I can just do it like that and just use this name, right? I had to first, you know, write it, then go back and rewrite whatever I had before, right? So it's kind of interesting. I just personally find this kind of stuff interesting. So key file path, right? And then we do knob da append, and we're just taking assets images, right? And we're appending the item, but then we're just returning the image that we loaded in here. That's basically it, I guess. That's basically it. So we are starting to have a little bit of a repetition again, but in a form, but in a case of the texture, right? So you could say that we do it like that. So we replace image texture, but with the texture, it's a little bit more complicated, right? Because you can't load, there is no such thing as load texture, right? You can only load texture from image, right? So you first need to construct an image, load an image, and then turn it into a texture. It's kind of similar to surfaces and textures in SDL, if you ever worked with SDL. In SDL, surface, I think it's called surface, right? So yeah, it is a surface, right? It's an image in a CPU, on a RAM. But texture is on GPU. So there is this kind of distinction. There is a CPU texture and there is a GPU texture. You can construct a GPU texture from CPU texture. The same thing in Radip, right? So image is a CPU texture and texture is the GPU texture. If you want to display it on the screen, you have to first transfer it to GPU. So, and because of that, so there's like we're going to have two layers of cache, right? To load the texture, to take the assets as a texture, we need to try to do assets image, right? Assets image. And there we go, we've got an image. We've got an image. So, and then we'll have to construct the texture out of that. But here's an interesting thing. I think we'll first have to try to find a texture within the textures, right? So we have assets textures. And if we found the texture, we can just return it. We just return the texture. If we couldn't find it, we have to create, we have to query an image because maybe an image was already loaded. So we can do essentially assets image file path, right? So we've got an image. So this is an image. Then we create an item that. So then we load it from an image. So this becomes a value. By the way, I just realized that this has to be a value. This has to be a value. And then we append that to textures. So this is how we essentially can do that, right? So texture doesn't load anything from a file, right? So it queries the image, and image already loads this kind of thing. So yeah, there we go. There we go. So, and we probably want to maybe abstract this kind of stuff away, right? Because we're literally going to have repetition for fonts, for instance, right? We're literally going to have a repetition for fonts, but maybe I'm not going to do fonts right now, but I already have the structure for fonts. Anyway, let's try to compile this entire thing and see what kind of problems we have in here. So this is the value. What else do we have in here? And this is the value, right? There we go. So for the fonts, it's literally as the images. It's literally as the images. Image, actually image font. Yeah, so that should be it. All right. So I'm going to think about how to get rid of this duplication a little bit later, right? So I'm going to think how we can get rid of it later. That should be basically it for now. I think we can try to go. And get rid of all of this stuff. For instance, full screen image, full screen texture, right? So this is the essentially the assets that we're talking about. Font, right? So we should not have a font anymore. I guess that's it, right? We don't really have that many assets anymore, right? But in the future, I plan to have a lot of different assets, right? And that's why I want to have the asset manager. So once I removed all of these things, let's actually try to recompile this entire thing, and let's see what's going on in here. So here we're loading the font. I'm going to, yeah, so this one is interesting because to load the font, you also have to specify the size of the font, and maybe that should become the key, right? So far I was thinking about the key of the asset as just the string, the path to the file where this entire thing is stored, but we also have different parameters with which, like for example, font can be rendered and everything. So yeah, because of that, maybe I'm gonna remove the fonts from the asset management right now, right? I don't want to think about it too much right now. Right, so let's just not have fonts. And right, so where is the font? I'm gonna bring it back. I'm gonna bring it back. All right, what else do we have in here? So, okay, so assets font, so this thing is not a thing anymore. So that makes sense. So we don't have to do that anymore. So that doesn't exist. And what else do we have in here? Okay, so asset, image, actually texture. And the texture that we need to load, let me find the path. Just a second. Yeah. Something weird is going on, but yeah. Where is the plug in it? So here is the path, right? So here is the path. And so this is what I have to put in here, right? So set texture filter. Ooh. Right, so you also have additional parameters and stuff like that. But maybe that's fine. I mean, yeah. Damn. So essentially we need to make the asset manager so you can have different parameters with which you sort of configure your asset, and that is part of the key. Right. So, and I couldn't see that up front either, right? So as you can see, the scope of the problem grows and grows and grows, right? So we can maybe move that set texture filter to the loader, right? So essentially asset texture, asset, where is the asset texture? Asset, is it assets texture? Yeah, it's asset texture. Right, when we are loading the texture, right, so maybe we want to set this thing, but that means that everything that I load through the asset manager is going to have this bilinear filter, but maybe that's fine. Maybe that's fine. Right. So let's just implement something that is working at least right now. Right, and in here, asset texture, right. So I lost my path yet again, so here is the path. So here is the path, and hopefully, yeah, so now it is compiling. So we only have one asset, essentially. We only have one asset. So, yeah, let's give it a try. Let's give it a try. So this is going to be build. And what was it? Visualizer. There we go. So probably want to actually run it slightly differently. Build visualizer. Okay, so it's loading everything correctly. So the reason why I want to be able to have this asset manager, right? For instance, now. I want to be able to add a completely new texture that I can render, right? So let's actually see if I can easily do that without restarting the application. The application is still running, right? So the application is still running. So now I can go to plug init and actually plug update, right? And at the end of this entire stuff, so let's actually find a place where we want to do all of that stuff. So we're currently rendering file dropped, So the music is currently playing. We're handling some things in here. We're not in a full screen. Okay, so somewhere at the end in here, I want to be able to just draw a texture, right? So do we have draw texture? So draw texture pro. So this is tags, right? So somewhere in the resources, I have icons, and not icons, but logo, right? So this is the logo. Can I, without restarting the application, just start, you know, rendering that logo? Can I just start rendering that logo? I think I should be able to. Right, so that should be something like this. So this is going to be just assets texture, and then I put this entire thing in here. So now I have to also provide the rectangle. So maybe I picked a wrong draw texture. I think I need to pick the one that doesn't require too many parameters. I think there was a simplified thing like that. So let's go to raylib somewhere here, raylib .h, draw texture, like this. So this one is a little bit easier to work with, right? I think. So this is going to be 0, this is going to be 0, the tint is going to be white, and that is it. Okay, so I'm going to recompile my entire thing. I didn't freaking, this is not recompilation, bro. Okay, so I recompiled, so it's still running, and now it's rendering. So essentially, I didn't have to restart the application, it's still running, but I added a new asset to it. Before, it was not possible without restarting the whole application, right? So because the assets was not a dynamic catalog that I can just expand at runtime. Now I can, right? So I can refer to the assets by its name, and I can just like straight up render it. It is slow, it doesn't use the hash table, the proper hash table, but it will in the future, right? So it will in the future, but right now it's fine. So one of the things right now that it doesn't support, it doesn't reload the assets, right? So for instance, I want to be able to all of a sudden start drawing a new thing and then modifying it and keep reloading it. To be able to do this kind of thing, by the way, I think we need to implement an ability to unload everything, right? So let's do assets. So we have image texture, right? So let's do assets, unload everything, like so. So, and what we're gonna do, we're gonna iterate through all the textures, right? So let's actually start with textures. So it's gonna be p assets textures, right? So this is gonna be count plus plus, and let's just grab the items of this entire thing and the values. So, and there should be a thing unload texture. I'm pretty sure there should be something that unloads the texture. There we go. So we're just unloading all of the textures, right? So simply unloading all of the textures, and then we can go and unload all of the images. Query replace texture, image, boom, right? So we're unloading all of the images. So, and when we are about to reload, right? So look at that. So we are about to reload the plugin, we're gonna go ahead and unload all of the assets, which will clean up the entire cache, which will force all of these calls to assets texture, reload everything from the hard drive. That way, we can even modify the assets and reload everything and have them updated. So, for example, I will be able to modify icons and instantly see how the icons look like in the application without ever reloading this entire thing. So it's gonna feel like a legit engine, a legit game engine. Right? So this is actually kind of cool. This is basically the dream that I had since starting this project, being able to just like hot reload literally everything. But I mean, there's still some things that you can't hot reload, but 99% of the things are going to be hot reloadable in here for sure. Right. So let me see. I forgot to do another thing in here. So after we unloaded all of these resources, we have to set the count to 0, right? So to indicate that we can reuse this allocated space. Right, so let's try to recompile this entire thing. So values is just a value. All right, so that should be fine. Unload everything. So we unload everything in here. Okay. So let me try to, let me try to run that. Let me try to run that. So we're gonna put some music in here. Okay. So I'm gonna put it in the background. Right. So this is what we have right now. I'm gonna try to go through this use case that I already demonstrated. Right. So full screen. Full screen button. So here is the full screen. Right. All of a sudden, I decided to draw a texture. I'm trying to draw a new texture that this application never saw before. So I'm going to do assets, texture, resources, logo 256, PNG. There we go. I'm going to draw it at 00 with the tint white. I'm recompiling the entire thing. And boom, it is available. Now, I don't like the color of the logo. I don't like the color of the logo. So I'm going to go into resources. And here's the logo. Okay, so I do have SVG in here. So I'm going to open it in Inkscape, right? So I'm opening it in Inkscape. All right, that's cool. So maybe I can just change the background a little bit. So because it's a little bit too harsh. So how about making it something like this? I think that's a little bit better. Okay, so let's take a look at the color of this entire thing. So fill, this is a gradient if I'm not mistaken. So what if I change this gradient to sort of like a reddish thing? The application is still running, by the way. This entire thing is still running. I'm going to save this entire thing and I'm going to recompile the logo specifically. So as far as I know, Nob has logo. All right, I'm recompiling this entire thing and here's the application still running and I just modified it. So I can tweak things around. For instance, I don't like the fact that it's facing one way. Can I actually, you know, change it and face it the other way, like so? Right, so then I recompile this entire thing. The application is still running, by the way. The application is still running. I can modify this entire stuff. So, and I keep adding new things and stuff like that. Funny enough, now I can go and remove this draw call. I probably have to rebuild everything. Right, and I can hot reload, and now this entire thing disappeared. And in fact, this logo even disappeared from the memory because when we hot reload, we unload all of the resources. So we unloaded all the resources and we never loaded that thing again. So it's fine. Right. So now every time I need to add new resources, I never have to actually reload this entire thing. Right, I never have to actually reload this entire thing. I can just work with that. So icons, like we have some icons in here. I can start working with icons. So let me see. So I have some resources. So here are the icons. Here are the icons. I can go open them in Inkscape. All right, so we have these kind of things. And maybe I don't like how this entire thing looks like. So, right, I don't even know what I can do. Maybe for this specific thing, I would like to make these corners a little bit more rounded, like so, for whatever freaking reason, right? So maybe I just like how that looks like when they're rounded. So I'm gonna keep them rounded, specifically for that case, right? I'm gonna save that. Also, I'll have to reconvert this entire thing. So background, non-full screen SVG, full screen PNG. I probably need to add that to the build tool, but I mean, it doesn't really matter. Right, and now the application is still running. The application is still running, but now it has these rounded corners, right? So I never have to rebuild anything. I can just modify things and reload everything. And all of that in pure C. Right, so, and this is because of this asset manager. And this asset manager is actually very dumb and very simple. Right, it's just an associative array. Right, it's just associative array. It would be, again, better if it was like a hash table, but it doesn't really have to. Right, when it becomes too much of a problem, when we have like too many things, we can turn it into a hash table. Right now it's associative array. In fact, when we turn it into associative array, we probably never have to modify any of the places where we call to assets texture. Right? We never have to modify this place, maybe a little bit, maybe a tiny bit, but not too much. Right. So isn't that cool? Chat, isn't that cool? So yeah, we introduced like asset manager, and now I don't have to restart the whole application when I just want to add a new asset stuff. So it's still, there are some limitations with this kind of thing, because some of the assets, when you load them, they require some additional parameters, like for example with the font. Right, so when you load font, you also have a font size, and this is because I suppose Raylib sort of like generates an atlas. It generates an atlas and sort of bakes the specific sort of resolution of the font. Right, so that's basically what's going on in here. And we need to come up with the asset manager that takes this kind of stuff into account as well. Right, so basically adds that to the key of the asset somehow. But that's kind of outside of the scope of the today's stream, right? So it's kind of outside of the scope of the today's stream. We spent like 2 hours working on this entire stuff, but I think it was worth it. I think it was interesting, wasn't it? Draw texture. Now I can. So it's drawing logo yet again. So let me see if I recompile the whole thing in here. Right, it is going to render this thing again. Yeah. And by the way, since I keep that SVG, right, so I store all of the assets that I modify here in SVG, I can revert the changes quite easily, right, then recompile the logo, just recompile the logo, and then reload this entire thing, and the logo is back to being normal, right? So, and logo is back to being normal. And all of that is without restarting the application. And it's not a dynamic language like C# or Java or JavaScript, God forbid, right? It's C. It's that scary language that memes on Reddit told you not to learn because it's old and scary and unsafe. Oh my God! Oh, this is kind of the shit you can do in it. It's just like, yeah, that's what you can do. It's easy peasy, lemon squeezy. Wow, never thought you can read data from files in C. Exactly. People didn't know that. People thought that you need to have like a multi-billion-dollar corporation and a huge team of PhDs to create a runtime that is capable of reading data from a file system. People didn't know that you can just do that in C. It's just like, what the fuck? Yeah. All right, I guess that's it for today. Thanks everyone who's watching right now. I really appreciate that. Have a good one, and I see you all on the next recreational programming session with Mr. Azuzin. All right, love you all.